My name is Toby Oetiker. I'm usually working as a system manager and have no idea about networking. But I have a sort of a hobby and I write network monitoring software. Just a question up front, who's using MRTG? Okay, so I can assume that you know about this. A few years ago, I worked at a place where I did networky stuff, and I ended up writing this tool, and it's grown since. So this presentation will be about a new tool I've written. It's called RRDtool, and it's a system to store and display time series data. And it does that in a very compact way, which will not expand over time. And it can also be used to present this data in graphical format. Sort of like MRTG, but only part of it and done in a more appropriate way. Oops. 29 slides. First, I'm going to show you some graphs of, well, which you can produce with RRDtool. Then I'm going to tell you about the roots of RRDtool, how it came to be. Going to explain how it's designed, tell you something about the implementation of the program and how you can use it in your own tools. Then I'll run down a short list of existing applications which already use RRDtool at their base. I'm going to have a little sales pitch about MRTG3. And finally, I'm going to talk about how to extend RRDtool in the future. And after my talk, there'll be another talk which will tell you about one possible way of using RRDtool. This is a graph showing the network traffic as it occurs between CAIDA and the internet. CAIDA's a place where I've been working for the summer, and they actually paid for the final development stages of RRDtool. This graph here shows the distribution of traffic between UDP, TCP, ICMP, and encapsulated IP. You can also do percentage graphs. That's the same graph, but every column is expanded to 100% so that you can see the distribution better. You see the little line missing in this graph? That's intentional. There's actually data missing. And in contrast to MRTG, RRDtool knows about unknown data. So if ever there is unknown data, it will not paint anything. It will not flatline. In 1995, I was working in the UK, and we had this 64K-bit link into the internet. It was a university with 20,000 students. So the link was pretty full all the time, and everybody was very interested in knowing whether it was down or just full. So I wrote this tool which visualized the link's status on the network. It used constant size log files, so I didn't have to bother with them filling up the disk. And I published the tool on the internet. It grew in popularity pretty quickly, and at the end of '95, I got a patch from Dave Rand of AboveNet, which speeded up the whole tool, so it became useful to people who had to monitor more than one 64K-bit link. But still, MRTG, as it got used on larger networks and people were doing more diverse stuff with it, it became sort of, well, patchy. People sent in patches which didn't quite match, but I applied them nevertheless. And MRTG, which you can get today, is very big. It does a lot of things, and it's like grown out of its original shape quite a lot. Especially, there was a lack of flexibility. People have started using MRTG to monitor things which I never envisioned, like the tide on Scripps Pier in San Diego. So in 1979, I started designing a new tool. The idea was basically breaking out the logging and graphing part of MRTG and rewriting it. So I was not going to write a tool which just collected data or create web pages, but which allows you to put data into a database and then produce graphs of that data. It is going to be fully documented. I actually wrote the documentation first and then started programming. It uses floating point math, so you can shove any numerical data you want into that tool. It doesn't require the data to be integer format anymore. It knows about unknown, and it uses a round-robin based logging mechanism, which is much faster than what MRTG did. And it has flexible and powerful graphing. In the following slides, I'll tell you about the implementation of RRDtool, how that logging works, how you can create graphs, some general points about how to use RRDtool, and the method for accessing RRDtool from within your own applications. Because somehow you must get that data into RRDtool and then tell it to graph the data. That's your work. RRDtool maintains a constant size log file which contains several data arrays, and it writes data into these arrays in a round-robin manner. So whenever data gets written to disk, the transfer to disk is actually only that one data value, and at the same time, the log file doesn't grow, so it's not just appending to the log file, but it's going round-robin in an array. So once you've set up the log file, you know how big it'll be. RRDtool can store data at different resolutions at the same time. So you can set up your log file to store data in 5-minute intervals, as well as 1-hour intervals and 1-day intervals. You can shove data into RRDtool whenever you want, and it'll figure it out on how to distribute the data into the different arrays. I'll have some more slides on this later. Data, when it gets distributed into these different arrays, gets consolidated. So you can tell it to store the maximum 5-minute value each hour, for example, or each day, or you can tell it to store the minimum 1 second average every year, whatever. This slide here shows you how this round-robin logging works. In this sample database, I have set up 3 storage areas. One which stores in 5-minute intervals, one which stores in 1-hour intervals, and the third one stores in 1-day intervals. As you can see, each of these round-robin arrays is at a different point in storing data, and it sort of rolls as it goes. When you set up a round-robin database, you use a command line tool which uses a specific syntax, and I'm going to talk a little about this syntax now. You can set up a round-robin database using or taking input from several data sources. For each data source, you define what name the data source has, what type of data source it is. So if you're looking at an octet counter on a router interface, you would use the counter data source type, be this here. Or if you're looking at the temperature of your machine room, you would use gauge, which behaves differently. A counter would be used to build difference between the current reading and the last one, and then divide the whole thing by the time which has passed between two readings and store the rate. The gauge data source type already knows what to store. It stores what comes into it. Then for each data source, you can define a heartbeat. That means while you have set up your database to store data every 5 minutes, you allow for example, 600-second update intervals. So you have a 600-second window where you can put data into RRDtool, and it will accept the data. If data doesn't come in within the 600-second interval, RRDtool will assume that somehow you lost connection to your data source and will store unknown. So if it happens that you cannot update your RD database, it will automatically know when the data becomes unknown. You can also define a minimum and maximum value for each data source. So this allows RRDtool to figure out whether the data you're providing is actually valid or not. So if you're turning off your router at some point and reset all the traffic counters and then turn it back on and start feeding that data into RRDtool, it will be able to tell that that data cannot possibly be valid. Once you have defined your data sources, you have to tell RRDtool how to store the data. And that's done with the second part of this slide, with the round-robin archives. For each data storage area, you have to have one of these entries. You tell RRDtool what type of compression or consolidation it should use to store the data. If you're getting data into your round-robin database every 5 minutes, you can set up a storage area which stores data every 5 minutes for, let's say, a day, and then have another one which stores data every hour, averages the 5-minute values into a 1-hour average, and stores the 1-hour values for a month or a year. And you can also define how many of these basic 5-minute input values must be valid in order to have a valid consolidated value. So if you're storing 1-hour averages, but get 5-minute data points as input, and you tell it that half of the input must be known in order to warrant a valid 1-hour average, you must have more than 30 minutes of valid input data for a 1-hour valid average. RRDtool works by using data rebinning. It's a new word. Rebinning means that when you're putting data into RRDtool, it may be that it's not at the 5-minute interval exactly. You're not able to provide data every 300 seconds because you have somehow got to query your routers or run your data acquisition software, and it will not be able to actually provide data exactly at 5-minute intervals. That doesn't matter. RRDtool is able to realign your data into the basic data acquisition interval you have defined. And this slide should give you a sort of explanation on how this works. In the first graph, you see the input you're providing. It's after 400 seconds, you have 280,000 octets which have passed that interface. RRDtool wants to store data every 300 seconds. So in the second graph, you see the context of this one measurement. There is a very low measurement first. Ooh, anxiety amplifier. There's a very low sample first, then a large one, and then a medium one. In the third graph, you see that it integrates over this space and stores the integrated value. So it doesn't matter when you're providing updates to RRDtool. It will always do the right thing. Unless you're surpassing this, let's say, 600 seconds update interval which you have defined in the first place. So if you're not providing an update after 600 seconds, RRDtool will say, oops, you've passed your limit, will store unknown for this period. These 5-minute intervals are called primary data points. That's what the PDP stands for. So this slide shows you what happens once you have your data rebinned at 300-second intervals, and you're going to store it into the round-robin archive. That's the original data, and then I have two round-robin archives. One which stores if the first one was, let's say, 30-minute intervals, this one would store every hour, and this one would store every 1.5 hours. So the round-robin archives always must be multiples of the original data acquisition interval. And as you can see, it's doing its integration thing again, integrating over the time passed, and then storing the average. And the colors you can see in the graph should give a hint on how this happens. In the slide where I set up the round-robin archives, you saw that there were different data consolidation methods available. This slide shows what happens if you have defined minimum and maximum consolidation methods. So instead of building the average, it picks out the maximal 5-minute or whatever the base interval was value and stores that into the consolidated round-robin archive. Okay, now you've stored the data in your round-robin archives, in your round-robin databases. You have accumulated a lot of data and you want to produce graphical representations of this data. In MRTG, you were limited to 2 data sources for a graph, basically incoming and outgoing traffic. In RRDtool, this limit does not exist. You can have as many data sources as you want. You can use different presentation methods. You can have a line graph, an area graph, or you can stack several data sources on top of each other, as you saw in the initial graphs on the second slide or so, which I showed. And you can do reverse Polish notation math on the data before you graph it. I'll have a slide on this later. This slide here shows a few samples. Just look at the first 3. They're probably useful, and the 4th one is to show off. And this slide explains how to do a graph. Now your routers will provide you with octet counts, and you yourself or your managers want to see bits per second. So you need to somehow convert the data between the 2 presentation formats. And this here is how it's done. This here defines, that's all on the command line, by the way. This here defines where the data comes from. It comes from this database. You're going to use the data source called incoming, which has been consolidated using the averaging consolidation method. And you assign this to the variable name A. Then you use reverse Polish notation math to multiply A by 8 and store it into the variable B. Finally, you're going to graph this variable B using hex color red and give it a label incoming. That produces a graph with one area type of presentation. It will look like the orange one here, for example. Now your traffic wouldn't look like this, but to get the idea. You have already seen now some RRDtool syntax. I'm going to lose a few words about this. RRDtool has many simple functions like update, create, database creation, one for graphing, one for dumping your database into ASCII. I have a slide on this later. Each of the functions has its own argument definition. So the graphing one has special arguments for creating graphs. The update one has special arguments for creating or for updating databases. None of the functions do exit or produce output on the screens. This allows you to integrate RRDtool into other programs without messing up the output. There is a way of getting output out of RRDtool, but it's controlled. So it doesn't just write to your screen or exit. It always returns. And there is full documentation on RRDtool on each of the functions, because, as I mentioned, the documentation was written first. When you're using RRDtool, you have an array of different methods to do that. First, you can use it on the command line. It's a simple utility. It's about 500 kilobytes in size, easy to use. Or you can attach it to a process via a set of pipes and pipe your updates into RRDtool via these pipes. This saves you the time you would use to start up RRDtool. And actually, if you're doing high performance logging, this is the only way to get a decent performance. RRDtool, if it doesn't have to start up for every update, can do about 1,000 or can log 1,000 data points per second. This allows you to do a lot of logging and have the consolidation in there as well. So it's not actually not only appending to a log file, it's actually maintaining the database. You'll never have to go back and consolidate. It's doing that on the fly. There are bindings for Perl, which come with RRDtool as a shared library. You can also build RRDtool standalone as a shared library and then load it into any program which supports loading in arbitrary shared libraries. There are bindings for Python and Tcl being developed. And there is a special version of RRDtool called DCGI, which allows you to write web pages which rebuild the graphs on the fly, sort of like PHP. Only the command set is much more limited than with PHP, obviously. Now, these two slides will give you a short rundown on which functions are supported in RRDtool. There's a create function, which allows you to set up new databases, an update function, which stores data values into the databases, a graphing function, which allows you to create graphs, both in GIF and PNG formats. So depending on your use, you can either abide by the patent laws or make your users happy. And there is a dump utility which exports an RRDtool database, which is in machine-specific format, into an ASCII format and allows you to transport it from one architecture to another one. And the dumping is also useful for debugging because it uses a XML type format once the database is dumped, so you can look at it and make sense of it. And there's a restore tool which goes back from the dumped format into the binary format. There's also a fetch utility. So if you have a RRDtool database which stores 5-minute values for a month, it's about maybe 10 or 20 lines of Perl to do a 95th percentile evaluation utility. And it takes about half an hour if you know Perl, I guess. There is a tune utility which allows you to modify certain properties of an existing round-robin database. There's a utility to find the current last sort value. So if you know the MRTG graph, there's always the current state of the network reported as well. With the last command, you can find this information. And there's a tool to resize your round-robin databases, or actually the archives within the database, which allows you to expand the amount of data which is being stored. Oops, sorry. This here is a complete example on how to set up a round-robin database. You have here two data sources. Each data source can have a name. They're counter data sources, so it would be interface octet counters probably. They have to be updated every 600 seconds. And the values which you're going to allow in these databases are between 0 and 10 base T Ethernet speed. And you're storing the data into 4 different round-robin archives. 2 of them store the averages. One stores the 5-minute averages for a day. The other one stores the hourly averages for a week. And then for the weekly one, you store as well the minimal 5-minute average, or the minimal 5-minute value and the maximum 5-minute value. Once you've executed this command, you get your RD database. It's filled with unknown values because there is no data available yet. But it has its final size. It will not change. Now you need to feed data into the round-robin database. This happens like this. Call RRDtool update function. Tell it which database you want to update. Then you can give a template which tells RRDtool the order of the round-robin or of the data sources you're going to update. And then you tell it to update with these 2 counter values. N stands for now. N can also be replaced by Unix timestamp if you have some more accurate timing information available for the update. And if you look at these slides in your notebook, you'll actually be able to read this here. If you have run update for some time, you have data in your database to create the graph. And this would be the commands needed to create a PNG version graph. I'm setting a lower limit here because everything in the graph is auto-configured. So if my data doesn't go to 0, graph wouldn't go to 0 as well. So just to be sure, I'm telling the grapher to go to 0, to plot the 0 line, so that you don't have a newspaper graph, but actually a useful one. I define variables for my 2 data sources, and then I plot the first data source as an area, and the second data source as a line of width 1. The second data source is the max, and the max has been evaluated for every hour. So you see the max is very jaggy, but it's built from the same data as the average, and therefore you can see that this actually works. It's always picking the max here and here. Now, if you're already using RRDtool, here are some points to keep in mind. RRDtool will store whatever you tell it to store, but it will also help you to make sure that you're only storing valid data. In order to enable RRDtool to do this, you must give it some idea of what data it's going to expect. And therefore, use these switches to define minimum and maximum values, to set up the maximum accepted input or update interval. If you're not doing this, you'll end up with huge spikes because you get some counter wraps or stuff like that. RRDtool tries to figure out if you're having a counter wrap, but it might miss some, and then it's better to have some min and max limits in there as well. RRDtool gets updated quite frequently, and if you're using the Perl module, you want to use the version number as well when you're loading that module, so that you're sure that you actually get the version of the module which you think you're getting, and not some other version which has been installed by some other person somewhere else on the system. This makes for quite some traffic on the mailing list, actually. And as I mentioned in the example, use lower limit when you're creating graphs, so that the graphs actually start at 0 if you have type of data which you want to see the actual amount of data, and not only how the line wiggles around. The most time-consuming task when using RRDtool is creating graphs. And therefore, I have developed a little tool called DCGI, which allows you to embed graph creation commands in a HTML page and have them executed once the page is loaded. So the graph gets only created when somebody looks at it. At the same time, the graph gets actually created. So RRDtool can figure out whether it has to regenerate the graph or not. So if a lot of people are looking at that page, it hasn't got to recreate the graph for every call. It only recreates it when it's out of date. If you're not programming and rather prefer to use a prepackaged solution, RRDtool seems to spark a lot of work in this area. The oldest one probably is Cricket. It uses a hierarchical configuration tree, which allows you to define your devices at the higher level and can build instances of them, sort of semi-object oriented. There is Orca, developed by Blair Sayak of GeoCities originally. And this one is for reading static files. So you have some other software logging to a file, and then you run Orca, which pulls data from these files. There is REMstat, which will be presented in the next talk, so I'm not going to say anything about it. There is FlowScan, where I just learned about it the other day. It's combining CFlowD and RRDtool for flow-based statistics. It's not available publicly yet, but you can write to its writer. And then there will be MRTG3 someday, maybe. It's not done yet because I've spent all my time developing RRDtool, but I have some initial work which sort of I've already planned how to do it. It's going to be object-oriented Perl, and the idea is that instead of writing a configuration file, I'll provide you with sort of basic building blocks for a monitoring application, which will make it very simple to sort of code your configuration. So I'll have Perl evaluate the configuration file. And it's going to use a tree structure as well, which allows you to leverage basic configurations and then have them tailored to your specific needs. If you want to be in on this effort, subscribe to this mailing list here. Also, RRDtool has some future work. I want it to be more flexible in the graphing area, even more flexible, and that will need some re-evaluation of how to do all these command line things. I want it to be anti-aliasing everything for even more beautiful graphs. I want to have the 95th percentile built in. And I'll review everything. So maybe the command lines will change, but the database format will certainly not change. So whatever data you store, it will be there. And I'll be using the Linux version numbering scheme. So 1.0 will stay the way it is, just bug fixes and maybe small enhancements, and 1.1 will be the development version. Yeah, that's my talk. I thank to AboveNet for paying the fare, and CAIDA for feeding me during the summer, and ETH for making it all possible.
Great, thank you, Tobias. We have a few minutes for questions, so go ahead and queue up the microphones if you like. I did have a couple questions I wanted to ask you. Since I didn't think anyone in this audience was going to ask, do you have a Windows NT version for this?
It does compile. It does compile on NT, but I'm not providing binary versions. There are people using it on NT, and there are these project files, I think they're called, for Visual C++, which are in the distribution. The distribution is tar gz, but if you're able to unpack it, it'll compile on NT.
Okay, the other thought was you're storing all this information into a database of some form. Is this a proprietary database, a structure that's published, or is it?
The database is built into RRDtool. RRDtool is available under GNU license. If you look at the code, there is the full documentation of the database format, with explanation of all the acronyms and everything. And the database is not like an existing database format, but it's a database format tailored to these round-robin archives, which allow fast updates.
Great. Any other questions from the audience? No? Hey, great job, Tobias.